guess I could share like just a portion of the screen.
This is why we needed that advanced GPU.
Yep.
So that you can live stream.
I don't even think this calls the GPU.
I think live streaming uses a lot. Maybe it doesn't. No, nothing. We're using 0% of the GPU right now. What was even the point?
That's the integrated GPU.
Oh, that's the
This is
integrated.
the actual GPU.
Actual. Okay, this
This
is fair.
12%. Fair enough.
Yeah. Okay. If you were live streaming like something that also uses the GPU, like doing some CAD or some gaming, then you need a good GPU.
Sounds like we should be gaming. Why is our feed black?
That's a good question. Why did we lose the camera? That was weird.
Yeah, that was weird. It just disconnected the camera out of nowhere. Nice. We're streaming.
This is officially live streaming.
Yeah. Lafuz is still logged into this account on his personal devices. So whenever I start a YouTube live, he gets a notification. And so he starts commenting on it with his proxy account.
Oh, nice.
Yeah.
Yeah. We'll see if he drops anything in the chat.
No, he's flying right now.
Oh,
yeah.
okay.
His flight was 4 p.m. Now let's see, this is the issue. See how it's oscillating?
Yeah.
It's because right now the output level is 56, which is perfectly divisible by 8, which is the
I hear it going.
yeah, it's the 8
Flipping
is the
back and forth.
discretization number it's the constant that I picked, which means
Yeah, we need to use a different method for
Yeah.
the controller. Like, it's working, but it's not really the best.
like this is as best as I'm gonna get right now, right? It's an oscillation of like maybe like plus minus 2 degrees Celsius.
I think just plug it in the wall.
And control it, but like control it with what?
Phase angle controller. Essentially a dimmer switch.
Yeah.
You know, like a dimmer switch for dim lights.
Phase angle controller. AC power supply.
You won't have all the noise issues.
Well, we don't have any noise issues right now.
Like you had with the DC relay.
Yeah.
Flipping on, because you're not flipping all the way on and off, because AC is always, here you go. AC is always already going on and off.
Yeah.
So it's just sampling. You can either have 0%, you can have 100%, or in between. So it samples a little bit of each one.
Yeah. So the effective output is decreased or increased.
Yeah, but the wave is always going up and down. You're not like forcing a DC curve to go up and down.
Yeah.
That's essentially how a dimmer switch works, like on your light switch.
Mm-hmm. These are always relays. Proportional controllers? No.
Backordered. The DigiKey probably has.
This is just same thing as a relay, isn't it? I guess we're
I
controlling.
don't think so, because the relay is like on off, and AC is already. What's the difference between a proportional controller? Is it just another name for the same thing?
Maybe. I think ultimately it just comes down to the same thing, doesn't it?
Yeah, but with AC, you're just going to have a lot less noise.
Yeah.
Oh, it's just a type. There are two types of proportional power controllers: phase angle and burst fire. So phase angle delivers proportional power to the load by turning on at specific points in the AC sine wave. So you're basically like controlling what part of the phase. Burst fire provides a series of full on-off AC cycles. So you go on for a bit and then you go off for a bit, and that's more like what your DC relay does.
Right.
But the phase angle controller is taking a little sliver of each part of the sine wave. So on each sine wave, on a complete wave, it's taking a little bit of this one and a little bit of that one. It's doing like, it's varying that proportion. It's sampling a little bit of each wave.
Yeah. Phase.
Yeah, so basically, that's your burst fire. You have like an on one and off one.
Yeah,
And that's your phase angle. It's like sampling a little bit.
Yeah.
You can vary that
So we
infinitely.
We want a phase angle.
Yeah. We already have an outlet that has 110 volts and however many amps.
Yeah.
I forget how many amps it is.
I know it's the high amp one. I just don't know how much. The input of this is also 120 AC input.
That's what our outlet is.
Yeah, but that's the output we want, not the input. The input we want to be whatever control signal we can send, right? And the output is what connects to the
We
wall.
can send it 110. We can send it whatever we want.
How do we control that signal?
So wait, am I reading this right?
Yeah,
the input voltage is also 120.
I'm not following this spec sheet.
How do you vary the?
It's here, right? The resistance side. So we vary.
How do you vary the amount of proportion? So the output side, I don't think the picture lines up with the stats because the output side is 90 to 130. So the input is also 120, but are you supposed to send it like a pulse frequency?
I don't know.
There's got to be like a spec sheet, and that would have more details.
Yeah.
I'd look on DigiKey because they're better with spec sheets.
DigiKey doesn't have it.
These ones are motor controllers. You only need a resistive one, though. Maybe just search proportional controller.
Yeah. It's essentially this, right?
I mean, it's like a type of AC relay, I guess, but it's a special type. Just want to make sure I get the right. AC proportional control. So there is an output type thing, isn't there? Somewhere?
I don't see it.
Weird.
That is weird.
But these are AC proportional
Yeah.
control. But there are ones that have DC input control. Like that's AC output.
DC input,
DC
which
input.
is kind of what we not want.
This is a 25 amp. Here's a 50 amp. Oh, so they have 3 different models. It looks like
Yeah. So it's
Or
just
like
the max amps.
different ones.
Yeah.
Yeah, different voltage and amp combinations. You pick the one you want, and then yeah, they operate on 60 hertz, which is what we have.
Okay, so how do you control? Let's see a control.
If it's like a 0 to 10 volt input, it's probably proportional, like on a scale of 0 to 10. Like if you send it 5 volts, it's probably doing 50%. If you send it 10 volts, it's doing 100%. So then you would just send it like an analog voltage.
It's
Probably.
the current.
Or it might be a frequency. Oh, they have, it can be
Yeah.
4 different ones. It can be on a voltage range, or you
Or
could send it current.
range, yeah.
Yeah.
We can flip voltage from 0 to 5.
Yeah.
Goes in there, on and off. Okay.
Yeah, and see, as you increase the voltage, it increases the true RMS. So that's basically varying the power as a percentage of line voltage.
And then this voltage.
So at 5 volts, you have 100%. At 0, you're 0%. Then it's kind of, it's not exactly linear near
It's
the
almost
ends,
linear.
but in the middle, it's
Yeah.
pretty linear. That would be like so much easier than like flipping relay on and off and finding like a stable.
Yeah.
Just with the amount of current you have when you're flipping it on and off like that, it's just making, I think it's making all that electrical noise, and that's part of the problem.
No, so it's not even electrical noise right now. It's literally just the knobs turning, right?
Yeah, but with
And
the
so-
old, like with the relay.
Oh, with the old relay, yeah,
Yeah.
correct, yeah. Right now, the issue we see in that oscillation, like in all,
Versus like when you use a dimmer switch to control your lights, you got it really smooth.
yeah. Like right now, it's about having to switch a signal that an output like a controller signal that gives me an output range from 0 to 100%, then converting that number to positions of the 2 different servos, right? That's what's causing the discrepancy.
Whereas something like that is like,
It'll be straight. It would have been really nice if we could just use the what's it called? I'm blanking here. The solid state relay we have,
yeah.
but it just makes so much noise.
Would it be better now that you're using the pyrometer?
I don't
Because
know.
part of the problem was with the thermocouple,
Yeah,
but maybe now that you're not using the thermocouple, it wouldn't be a problem.
it's possible. I didn't try. I could. Would it help us get a smoother profile?
But is this smooth enough to get the data you need to finish this work also? Because if it is,
Right now?
then yeah.
Yeah.
So maybe just let it be for now.
Yeah. Oh, because ultimately I have my controller programmed so that if I want to, I can switch to a variable voltage control, right? Right now, I just set the solid state relay to be always open, and then I vary the current by clicking on the auto current. But I can just let the current be always 100%, and then make it voltage limited, and just control the voltage controller side. So it'll be essentially controlling a solid state relay. It's an option.
Yeah.
This
I keep thinking like this is how we should have done it from the beginning, but
maybe. I also think Dr. Menon would be a little bit worried about me splicing a high current AC cable. Just hooking
we're
this.
already doing high current DC cables.
Yeah, but high current AC sounds more dangerous.
I guess.
Yeah. High voltage, high current, that's like recipe for death. It'd be funny if we short something on this floor. I become the cause that a lot of people's devices just die. I also wanted to add a physical contactor on this thing. Not that. Yeah, mechanical.
Don't you already have one?
I have the circuit breaker, right? What's the coil voltage? Yeah, something like this. Just feed it a signal and it just mechanically opens and shuts.
That would be nice.
Yeah. Ultimately, because what I want to move towards is I can leave the circuit breaker on, and
But
once
be able to deactivate it.
right, once a certain like serial communication is all open and everything is prepared to start an experiment, then once I click start, this closes and it starts the experiment. That'll be ideal.
That makes sense.
So much data. Jesus Christ. And still, it's running without issues. That's a very big plus right now.
Yeah, that's good.
We're halfway through, which is good. This is 200 cycles total. Pretty solid. What are you looking at? Electronics.
We're live streaming right now.
I saw that.
Yeah. We're on
Welcome
YouTube.
to the live stream.
Fantastic.
Yeah, you're famous now.
Yeah.
Nobody's commenting yet. What's happening?
That's great.
Yeah, where's the
Great.
foods?
Yeah, he's on a flight. It's understandable. I sent it to the group chat. I printed 2 X-Wings one time on this 3D printer. I found a guy that has a model of the X-Wings just ready.
Just download it and go.
Yeah, that's what I did.
How'd they turn out?
It turned out
Very
really.
good.
They
Oh,
turned
nice.
out really well, actually. I was genuinely surprised. I have a bunch of 3D printing things. Yeah, look at that. It's pretty solid.
It's pretty nice.
Yeah. These are X-wings. You just print in place.
Oh,
And
okay.
the wings even close. It's actually pretty cool. That's not what I'm printing right
I
now.
was like, this is what is drawing Mike's attention.
Yeah, this is what we're doing.
I was like, all right, good use of a Friday.
But yeah, they print really well, and you can also just linearly scale the size to make it bigger.
Someone called your print mid.
Yeah, that's Mafuz. I don't know
Nice.
why he has access to Wi-Fi right now. He should be on a flight. Maybe his flight got canceled.
Or he paid for that Wi-Fi. Who knows?
Oh, that's a Mafuz thing to do. I am dead ass on a plane. This guy. But you ever play the old game Command and Conquer?
Oh, I remember
You
that.
talking about, yeah?
Yeah.
It's the Mammoth Tank.
Oh man.
You know those?
I remember these old games.
Steven, you ever play Command and Conquer? He's too busy. But these also print pretty well, and you just there's a little cutout there for the turret to sit inside. So you just print it and you just place that thing together.
Nice.
Pretty good.
Just seal it up with some vacuum grease.
Yeah. What else would you possibly use? You could print a pretty big X-wing on this thing.
Well, so much potential. Oh yeah, this is something I was curious if I could do the print, but this is like a multi-day print. This is just part one. There's multiple plates, AT&T. So this is the head.
Oh shit! Okay.
Yeah, this is the head
yeah,
of the turret, and here's the body. Alright, and the legs, and the other legs. But this whole thing, dude, takes way too long to print. I cannot justify. I cannot justify printing this thing.
How many days does it take? Like a long weekend?
Let's take a look. Actually, I'm curious now. Print my passport? No, not happening, dude. Oh no! I killed Bamboo.
It's dead.
Bamboo died. It's way too much. Why would you buy Wi-Fi on a short haul flight?
Maybe it came with the flight.
No way.
No
dude.
way.
There's absolutely
They don't give
no
you
way.
anything anymore.
No?
They don't give you free
They don't give you
Wi-Fi. What are you
anything.
talking about?
You barely get a cushion
Some
on
of
the
them-
seat.
Yeah.
So you get like free messaging and emails.
Okay, yeah, you get free messaging, but like enough to watch a
He's
Enough
YouTube
to
video.
streaming
Enough to stream
He's
YouTube.
live watching
Yeah.
a YouTube live. That's insane.
That's some
What's this guy?
decent Wi-Fi, like at that, you know.
What? Why am I not seeing my AT&T? Show me my AT&T. No, it's not AT&T, right?
It's AT&T.
Yeah,
Yeah,
okay, there we go.
You're thinking of the
The company.
communications company.
Boom.
2 hours.
This
It's just
this,
that
yeah, this
part
plate.
of the print.
Yeah.
So all plates,
Oh, that's not that bad.
11 hours.
11
22
hours.
minutes. No, it's not bad at all.
You just stay overnight,
Not bad at all.
swap them out. You could do that
Yeah.
overnight.
Okay, for some reason it just keeps getting rid of that. I'm gonna
ban Mr. Toilet 1918. This guy is toxic.
Mr. Toilet
1918.
1918.
That's this guy's fake account when Mufuz wants to shitpost or watch sketchy videos, but he doesn't want it to be known that it's him. He uses Mr. Toilet 1918.
That's good.
This guy.
You need one of those. You need an alt account if you're gonna do that.
I can't believe that your idea of entertainment on a flight is to watch some dudes running an experiment.
I mean, what else is he gonna do?
I guess so.
There's nothing to do on a flight.
I guess so.
You can look out the window. Except you can't see the stream anymore.
Let me
Yeah, share
give you
screen.
let me give you the stream back so you can look at something.
Oh yeah.
Yeah. All right, that's better. And watch it with whoever's sitting next to you. Be like, hey, this is what I do for a living. Yeah, I can't stream out of the laptop anymore. It's
Not powerful
it's
enough.
not powerful enough.
That's why we have the high performance PC.
I hope ideal if I can run the experiment off of this machine, but that'll be grossly overkill.
But this works. You can just stream it from this one.
What do you mean?
Like run it on that one, but then stream it here.
Eric's
Eric's
watching
are
this.
both-
too.
He doesn't have anything else to do.
How would I stream my experiment from this machine?
You're gonna have to come up with some things to talk about during your stream. That's a long time.
I need background music. That's what I need.
Background music.
Yeah. Public domain background music.
You could do, you know, those videos where people eat food on camera. You
Yeah,
could do those.
And leave record
Just
and
like
evidence.
chewing into the camera.
Leave
Like-
evidence of me eating inside the lab. Oh, you ever seen this before? It's the cat
I
mouse.
like that.
Yeah.
It's a nice.
I got this from the IT department.
Yeah.
It's actually pretty solid. Like it's just
It's so much better.
yeah, you can move things around pretty easily. I also set up some hotkeys. Let's say, for example, say for example, I have this, right? This right button is the dimensioning button, right? So if I put another sketch on this thing, just make a circle, just tap the right button and I can dimension right away.
That's pretty
Yeah,
nice.
that was pretty good. That was pretty good. One thing I do wish this thing offered is if you were able to do like a perfect isometric view just by pressing a button.
Could
Right.
that be a hotkey?
That could be a hotkey. I forgot what the other hotkey was. 3D connection. There we go. Alright, buttons. Oh.
SolidWorks. Oh no. No.
Did it delete your setting?
I think so.
Yeah, you have to redo it.
Oh, sick. Mega election. Guess who's gonna win? Me.
Who's running?
Me.
That's you.
I think there's somebody else running as well. Whoever's watching this stream, if you can please vote for me, thank you very much.
Are you running for two different things?
Oh yeah.
It would be funny if you wrote the same.
That would be hilarious. Yeah.
I like that person's.
That's pretty solid, right? I love to work out and hang out with friends during weekends. I think that's a
pretty normal person.
Yeah.
I would vote that person for social chair. I mean, this person running for social chair wrote how people who know how to have fun are the ones who know how to do work. It's not social chair material.
sick. It's an insider job. See, okay, one thing I don't understand from this is what's that P1?
P1.
P4 is that range that we feed it.
Yeah.
P3 is the on-off control. It's a digital 1 or 0. P2 ground. P1.
I wonder if it needs, like, maybe it needs a reference voltage to compare the set point against. Like if you're on the 0 to 5 range, you need to give it 5 volts here, and then this one is your 0 to 5.
Yeah, but then it says 8 to 32 volts DC. Not exactly following how that makes sense.
It could be anything
from 8 to 32. Is there any explanation on how this works?
Probably in the spec sheet somewhere. All of it.
Oh, wait, no. Okay, so whatever version we buy, it'll be capped out on the analog control signal.
Okay. So that's a purchasing option.
Yeah, it's a purchasing option. We want A.
Yeah.
Okay. That.
Can we go up some more? So if you got, you got option A. But then how does the wiring go? So P1 is your
10K to 50K pot for options A, B, and C. Okay, that's just to adjust the input voltage from 0 to 5.
That's if you were just using a constant power supply. You could use a potentiometer to vary it, but you could just set it up with like an Arduino that's sending an analog voltage. It doesn't have to be a constant. But it looks like you need to send it the reference voltage to P1, and then you send your variable
set
one
point
to the set point
yeah,
one.
P4. Maybe there's a different. Okay, analog inputs options A, B, C, D.
Yeah.
Well, okay, it doesn't show them.
Yeah, because it describes it down there. That's what it looks like to me. You need to send it the reference voltage on P1, and then you send it your set point.
So this is a pretty viable option. Screw terminals, reselling. I like this option.
Yeah, so you just need to plug your heating element directly into the wall.
I mean, because we already have the plugs
Yeah.
to go into the glove box anyways. It's just about switching that out. And we wouldn't have a power supply anymore. And we would get
You wouldn't even need a power supply. Yeah, you would just vary.
we just vary
output on
this. I like this idea.
If the current lines up, right, you might need like the 50
Yeah.
amp version.
I don't even know what the AC power requirement would be for our setup.
We'd have to figure it out.
Yeah.
I mean, it'll be a little bit more than if you're using DC because it's not quite as efficient at heating.
Yeah, but ultimately, don't you just have to take the area under the curve for an
Yeah.
AC curve, right?
It's just like the RMS.
Yeah.
If we calculate it based on the VRMS, then we should be getting a similar
Yeah.
idea, right?
Yeah, it'll be a little bit less than if you had the same voltage and current with DC.
I've gotten into the habit of applying to people with GIFs.
That's funny.
Oh, Maddie's watching this too.
Oh, nice. Hi, Maddie.
Morel 9050.
What's her username?
Madeline Morel 9050.
What you guys didn't realize was that this was actually an attempt to learn all of your YouTube usernames, so we can look at your history.
That's a good one. Is there a way you can? Oh wait, there are 3 viewers right now. But does that mean that there have been 3 views so far?
I don't know. I've never streamed before.
Yeah, me
so
neither.
I don't know.
I was always just streaming without caring if somebody watched or not.
I really do feel like getting a double pull, double throw relay and hooking up the actuator to it so it can go backwards and forwards.
On the actuator?
Yeah.
What's going to go backwards and forwards?
The actual actuator is going to go back and forwards, and
But
it's going
to do what?
it's going to flick off the circuit
Oh, okay. Yeah.
so that I can remotely break the circuit. I think that's a great idea.
That's too useful. It needs to do something really dumb.
What else could be? How about? Oh wait, no, I got it. I can hook it up to go like sinusoidally backwards and forwards, and have my mouse attached to it, so it makes it seem like I'm active on Teams.
A mouse jiggler, yeah.
Okay, that's more useful. Dude, what I actually wanted was what's that called? Like the clamp on ammeters. Right,
That could actually work.
ammeter, isn't it? Am I spelling that incorrectly?
Is it
Is it
ammeter? I think that's right.
Ammeter?
No, it's ammeter. Yeah, like those.
Oh,
The picture of it was right there.
today. Yeah, that one. Okay. I learned that in DigiKey you have to. Oh wait, none of them are available.
That's not-
There we go.
I feel like that's something you just get at Home Depot.
That's fair. Yeah. Can I share this with someone? My God, can you print faster?
You're like halfway.
Yeah, it's exactly halfway now. I remember a buddy of mine that works in
We
additive
lost all of
manufacturing.
our viewers.
Oh,
Bored
nobody,
them to death.
nobody's watching anymore.
Nobody's
No,
watching.
no. I know. So, one of my guys in additive manufacturing told me that the limitation for additive manufacturing is not the controls; it's the thermodynamics of it, of having a material hot enough to dispense quickly and cool it quick enough to add more on top of it is the limiting factor. That you can control that motor to go in supersonic speeds very easy.
Yeah.
Yeah, this is what we want, right?
They're not the most accurate, though.
They're not the most accurate, I know. That's why the range is up to like what, 400 amps? Yeah. Who needs 400 amps?
Electricians. I don't know.
Yeah, you're
That's
right.
a lot. 400 amps.
Because I know Rich uses these for his solar panel metering, and he has it connected to a display.
Yeah.
You can do it. You can do it, buddy. The print is coming out surprisingly well. I'm happy about this. Let's see how the experiments.
That's good.
Maybe I'll
Pretty stable.
maybe I'll have my undergrad over the summer beautify my VI a little bit.
Owen did a really nice job with Maddie's.
Yeah, but I honestly don't agree with the philosophy of that VI.
There are a couple of things I would change.
Yeah, it's also it's too pretty for the amount of functionality it
It's
has.
too pretty.
Yeah,
Okay.
like functionality comes first.
I think it looks nice. You could have something very functional that also looks nice.
Right. But then if it just looks pretty and it doesn't have that much functionality, I don't think it's good enough.
It has pretty good functionality, but there are a couple of things I would change to the
Yeah.
way that it works, just to have a little more manual control. over
Yeah,
things.
yeah. And that's why I always have this manual override
Yeah.
available. Okay. Like at any given point, if I just unclick this button, then I can set the current to whatever I want it to be and control the valves as well. But you see this? So that's the sample temperature on the left.
Mm-hmm.
So we're at like 850, right? Pretty solid. The gas temperature right now at the outlet side is 151 degrees C.
Pretty big temperature drop.
Yeah.
That's what you want, though. You don't want you don't want the buses getting that hot.
Yeah. I mean, so like this is just showing that it actually is doing as it's designed to do. Right?
Yeah.
There's not a lot of conductive surface area for heat to transfer.
Yeah, you're not getting heat conducting out of the ends.
And ultimately, there's not a lot of heat transfer between the gas we're flowing and the heating element itself. It's just not ideal. It's quite literally just like a flow over a flat plate type of situation, but the flat plate is tiny. So many things to add.
I should head out.
Is it Robbie time?
It's Robbie time.
Yeah, it's Robbie time. Nobody's watching anymore. I'm gonna kill the.
Yeah, might as well kill the stream. Now we have everyone's username.